Welcome to all. Myself Spandan Babar from Arts Commerce Science College Ozar. Today I came here with my project Concentrated Solar Power of a Central Tower Receiver using Heliostat Mirrors. Come on, let us start our project.
As you are seeing, our project, Concentrated Solar Power (CSP), is a fascinating technology that harnesses sunlight to generate electricity. One innovative approach within CSP is a central power receiver, which utilizes heliostat mirror to concentrate sunlight onto a single point at the top of the tower. Let us understand about receiver. At the top of the tower sits the receiver. This is where the concentrated sunlight is collected and converted into heat energy. The receiver is designed to understand assembly the receiver. There are two components, the hot receiver and the cold receiver. The hot receiver is where the concentrated sunlight is directly heated up and a heat transfer fluid such as melted salt and a heat transfer oil. In some CSP system, water is used as a working fluid. It is heated to produce steam, which then drives a turbine to generate electricity. The heat collected by a receiver is transferred to water or another working fluid, turning into steam. The high pressure steam is then used to drive a turbine connected to a generator and produce electricity. A water tank is often incorporated in the CSP system to store water for steam generation. This allows for a continuous operation even when sunlight is not available, as the stored water can be used during cloudy period or at night.
As it was a descriptive of my project. Consider lamp as the source of the light. Like a sun, the light is being incident on the mirrors and the receiver is being heated. Let us see an animation of my project.
Once again, welcome to all. I'm Spandan Babar. Now, I'm explaining about my project, the Central Tower Receiver using Heliostat Mirror. We will now outline the procedure using a block diagram. Come on, let us start.
Concentrated Solar Power, CSP. CSP systems concentrate sunlight using mirrors or lenses onto a small area to generate heat. Unlike photovoltaic PV systems, which directly convert sunlight into electricity, CSP systems generate thermal energy, which can then be used to produce electricity through a steam turbine or other heat engine. Central Tower Receiver. In a central tower's CSP system, a tall tower is placed at the center of a field of heliostat mirrors. These mirrors track the sun and reflect sunlight towards the tower. At the top of the tower is a receiver where the concentrated sunlight is collected. Heliostat mirrors. These are large mirrors that are individually controlled to track the sun's movement throughout the day. They reflect and concentrate sunlight onto the central tower receiver. The precise control of these mirrors is crucial for maximizing the amount of sunlight collected and the efficiency of the system. Receiver. The receiver located at the top of the central. Receiver. The receiver, located at the top of the central tower, absorbs the concentrated sunlight. This intense heat is used to heat a fluid, such as molten salt or a synthetic oil, flowing through the receiver. The heated fluid is then used to generate steam, which drives a turbine to produce electricity. Heat storage. One advantage of CSP systems is the ability to store heat for electricity generation, even when the sun is not shining. This is typically achieved by storing the heated fluid in insulated tanks or using solid-state thermal storage materials. The Heliostat Mirror Control System, Heliostat. This is a hypothetical term you've mentioned, presumably referring to a control system for the heliostat mirrors. Such a system would include software and hardware to precisely adjust the orientation of each mirror to track the sun's movement accurately. Advanced algorithms may be employed to optimize the positioning of the mirrors in real time, taking into account factors like weather conditions and the changing position of the sun. In summary, a CSP system with a central tower, receiver, and heliostat mirrors is a sophisticated way to harness solar energy, utilizing mirrors to concentrate sunlight onto a receiver for electricity generation. The precise control of the mirrors, along with efficient heat collection and storage, are essential elements for maximizing the efficiency and reliability of such a system.
This was my project, and I am grateful to Dr. B.P. Bangare ma'am, Dr. S.Y. Sardar ma'am, Professor Shimparkar ma'am, Professor Nikwe sir, who supported me for my project and encouraged me every time for doing this. Finally, this was my project. Thank you.